Okay, Leyland. Yes, let's start with just a little bit of your background, yeah?
Okay, good, Roger. I started in ag chem development with a couple of large multinationals. As you can hear, I'm Australian, and my ancestors were brought here as convicts because that's how Australia was settled. So we have a fantastic gene pool here. The best that the British had, they exported. So that's where I come from. So I started at ag chem many years ago. And one of my first projects was towards the dying phases of DDT. So my vehicle was actually, the number plate was DDT 007, which I thought was quite smart for a while, till Rachel Carson's book came out and I realised the fallacy of all that. So I've been in ag chem research, and then some years ago I was poisoned accidentally twice with chemicals that are developing. So that got me thinking that there must be a better way. And so that got me on the path of developing organic based products for inputs into agriculture and horticulture, but products that work and were backed by science. I was fortunate enough to go to Stanford University and to Cambridge, and I met a lot of very eminent people that got me on the path that I'm now going on now. So that's my background. I'm getting close to 80, but really only 40 in actual health. And we've set up based on technology I have and my partner, a biotechnology company. We have funding from our only partner in the Middle East who's interested in food production. So the company is called South Pacific Biotech, and it's based on the Gold Coast. Those who have not been to Australia, it's sort of a bit south of Brisbane. It's subtropical, and around this area here we grow macadamia nuts, bananas and sugarcane and avocados. So it's quite a rich area, and it's a good area for doing experiments or trials or tests. And there's a farming population here quite interested in reducing their chemical inputs. So it's a good area to be based. And I've known Roger for probably 10 years now. And
it's a little bit longer. Time goes fast. Yes. More like so 15, 16.
I've worked in Pakistan and India and all through Southeast Asia, Kenya, South Africa. So while I was in the ag chem research side, where we worked with insect contraceptives, which are standard practice now for mosquito, and stored grain control and pheromones, sex attractants, so we could attract the pest to a point where it could be poisoned. So that was my basic. And the original organophosphate insecticides, my boss in England actually led the Allies into the German chemical industry, where they discovered the Germans had developed these very toxic organophosphate compounds. And so my first job really was developing these for many uses, but they've now been banned because they had a lot of secondary effects that we weren't aware of then, till the stage where now we are developing products which are vegan, not because we think that's smart, but we probably the first developing nitrogen, which is most important for growing crops, but based on vegetable proteins. Organic farming, they can use their nitrogen source from fish or from blood and bone, from waste animals, etc. We've gone one step further where we can produce a nitrogen from soybeans and or from microalgae. And so, excuse me, and that's where we are at the moment. But along the way, I met some people, it must be Roger, I suppose 10, 12 years ago, who introduced me to Ormes, which was then called Ormes. We tend to call it Ormes, orbitally rearranged monatomic elements. Excuse me. And these are, should we go on with this now, Roger? That's my background. So I have a practical background in agriculture, horticulture, hydroponics from the chemical age, and I progressed through the organic age, and now we're up to the vegan age.
So Leyland, can you actually see the slides on your screen?
Yes.
Yeah. So what we'll do is let's follow the slides because it gives it a little bit of structure. So essentially, Leyland's developed a number of products with some unique ingredients, as you can see here, and we will talk about this in detail. And for instance, the products here, as you can see, the Gotcha is a organic herbicide, weed killer, a good substitute to Roundup. On Guard is an insecticide, what we call Vigor Grow, a fertilizer, Fungo, a fungicide, and Natroponics we consider very revolutionary to the hydroponic industry. So let's talk about Ormes first, and we'll go through some of these unique products. So tell us about your journey with Ormes.
Okay, all right, Roger. I was introduced to this, and I'm always interested in the technical side of things as to why they work or what they are. For instance, I introduced seaweed, but the actual actives in seaweed into Australia. And like I said, I worked with these insect contraceptives. We could stop insects growing up, with passing through their life stage. So I got involved with Ormes or Ormes and found out a relatively simple way of getting them, but it might be simple, but it's difficult to achieve a good product. It's a bit like making a sponge cake. Everyone knows that what a sponge cake is flour and sugar and whatnot, but very few people can make a good sponge cake. And so these Ormes is something similar. We know what it is, we can make it, but to make a uniform product that could be commercialized is the difficult thing. Now, the method we use, we do it in some thousands of litres of end product at a time. We use very clean seawater, pristine seawater, and here where I am, we're very lucky. There are no large rivers emptying into the sea within 100 kilometres of where we collect the water. And this part of the world, the sea is quite clean. For instance, you'll walk along the beach here for a few kilometres and you won't find a single plastic bottle or a bit of plastic or a toothbrush or anything like that that's washed up. So, or a thong, you know, a rubber sandal. So we use very clean ocean water, and we tend to take it on a high tide, with the tide coming in. And so it's water that's come all the way from, I guess, South America, really. And so that's the water we use. Now, what we get, if you can Google up seawater, and you'll see what the seawater is made of. Now, when we have excuse me, we would get about 2% of a white milk from the seawater. So 1,000 litres, we end up with 20 litres of white milk. And when we had this analysed, and this is quite a reputable company, it does a lot of work for the mining industry, and it's an accredited government laboratory, we found the major component was, or first of all, there was 40% of this white milk that they could not identify. So originally we said, well, repeat that, you've obviously made a mistake. So they repeated it, I think 3 times and got the same answer. 60% we knew what was there. And of that 60%, the majority is magnesium. If you're getting these Ormes or Ormes from seawater, and it was about 12,000 milligrams per litre, and 1.2, grams. Potassium was next at 1.3. Magnesium was 12. Potassium was 1.3. Then calcium, 1.1, which I thought it would be more because the sea has a lot of shells and coral and things like that, but it was only 11 in our, what we got, 1,100 parts per million. Sulfur was next, then phosphorus, then silica, then boron, and then you have a lot of the trace minerals. So you have a little of copper, a little of iron, a little of molybdenum, etc., which you'd expect. But magnesium by far was 12 times more than calcium, about 10 times more than potassium, but having the potassium is a very good thing, and sulfur, phosphorus. Now, magnesium, potassium, calcium, and phosphorus are the key things in growing plants, plus nitrogen. They are what we call the macronutrients. So in this, what we got, this Ormes, or what wasn't the Ormes, but the other part had the key things. Now, this 40% that couldn't be identified, this is the Ormes or Ormes part, and it's there because I can see it. We touched it, we felt it, but these analytical companies here don't have the equipment to identify it. And so these are these orbitally rearranged monatomic elements, which if you read around the subject, are found in the platinum group. That's gold, silver, rhodium, iridium, platinum, copper, and have been formed in volcanism under high temperatures, etc. And like high mountains, we have a mountain here called Mount Warning, which is about 3,000 feet. Well, it was much higher, been eroded into the sea. It's volcanic plug, so all that material has been washed into the sea. So that's where these Ormes or Ormes came. So with these minerals, these beneficial minerals we know that plants grow, plus these Ormes, you have a miraculous material. And there's a picture up on the top right-hand corner that Roger has shown here.
There you go, you're back. Okay,
yep.
Carry on.
Of a lettuce crop. Now, that particular farmer there produces 2 million units a week. I don't think that's lettuce, but anyway, this particular farmer, 2 million, and that's mainly lettuce, cos lettuce, the frilly red ones, etc. And he found by just spraying once every 5 days over that crop with 5 mils per litre of this Ormes product we have, that he could increase the speed of growth. Now, normally they'd grow here in Australia about 10 crops per year of this hydroponic, but here he could grow 11 crops. An interesting thing he said, and I've heard this repeated many times, that under cloudy weather, he'd expect the crop to be growing much slower. It didn't. It grew just as fast. In fact, and it grew quite fast under moonlight conditions. grew so fast originally in these cloudy conditions that he'd programmed his deliveries to the various retail outlets, and he had far more crop than he'd programmed from what he usually had. And I went to some of these retail outlets, and these are very large shops Roger would be aware of in Sydney. And I said, how's the lettuce that you're getting from this particular grower? And they said, well, these things have changed a bit. They're really good. They've got a long shelf life, better colour. They've got nice white roots because they supply the lettuce with the roots on. And they said the best part, longer shelf life. They didn't wilt. They didn't look, we didn't have to spray them so often to keep them crisp looking. And of course, the reason for that is that the lettuce have taken in more minerals, replaced water with minerals, and so you get a longer shelf life, better transport life. And that's just spraying with the material. This is this Sea Vigor, we call it now Sea Vigor product, across the top of the lettuce. Now, you'll have noticed when I gave the analysis that there's no real quantities of nitrogen in the seawater. Now, there's a bit of gaseous nitrogen. So I did experiments where I grew things just in cocoa peat, which is a sort of a chopped up coconut husks, and it's replacing peat. Now, mining peat is not environmentally very good, and it's being phased out all around the world. In fact, I worked, the first multinational company I worked with was based in England, and they had huge peat mines, which are all closed down there in Somerset. So I grew these plants in cocoa peat. So no nutritional value, just drench them with the Sea Vigor, which is the Ormes product. And they didn't grow very well at all. I planted seeds and they didn't grow very well at all. When I got some soil or potting mix and planted the plants, they grew really well. So the second lot, the soil or the potting mix had natural nitrogen in there. So we can supply everything the plant needs except the nitrogen. And so we went on to develop, and we'll talk about that later, the vegan organic nitrogen.
Yeah, for instance, our next slide here, we'll go through some of these unique ingredients. But we might as well follow the slides here. Let's talk about the diatomaceous earth that we're using in On Guard. There's a product called On Guard. And so, yeah, tell us a little bit about diatomaceous earth.
Good. Well, what I'm talking to you about is possibly the first company in the world that went about and have designed a range of products that would service the market requirements. And we're targeting on medical cannabis because it has to be organic. But in general, most farmers here in Australia are keen to go organic, and they're going regenerative and such like. Now, so this product here, we've known, and it's been known all around the world that for controlling insects, you can use amorphous silica or diatomite or DE, diatomaceous earth. Now, diatomaceous earth, it's a white powder, or it's a white rock, really. I should have had the sample here to show you, but it's very light, and it's made from the skeletons of diatoms which floated in volcanic lakes, which were very high in silica. So these masses of diatoms, and they fell to the bottom and have beds of it. And luckily in Australia, we have some very large deposits which are free from clay. And these are the shells of these diatoms. They're extremely small. You need an electron microscope to see them. And they're like a tin can with holes all through it. And so the beds of these not far from here, they're about, in meters, about 10 meters. So it's a lot of diatoms. And we mill it down to around about 10 microns, and it'll hold probably 10 times its weight in water if you want to. But they're made of silica dioxide. And silica dioxide is very hard on a hardness scale where a diamond would be 9. It's about 7. So you see this very light rock, and you know the size of a, say, a 20-litre drum. Well, I could easily hold that just in my hand, just like that, so light. So this very hard, light rock we mill, so you can dust it onto plants, but it leaves a white mess, white powder everywhere. So some years ago, another friend of mine, we looked at turning it into a liquid. Now, about 15 years ago in Australia, or 12 years ago, we used so much chemical on our cotton. Now, in Australia, we grow the best cotton in the world for a certain reason. Very long staple and very high yields because they're grown in ancient lakes. It's black soil that sticks to your feet. So whenever you walk around there, it's best to walk in bare feet, not shoes, because it sticks to you. Anyway, we're spraying the crop 15 times a crop. So we've got multi-resistant cotton bollworm, which are called Heliothis. So just at that time, this friend of mine decided we'd look at this diatomaceous earth, but we could make it into a liquid, because in Australia, because of cost of labour and lack of labour, everything is mechanical. So the crops are all sprayed by aircraft, but so we had to have it liquid, and so we liquefied this DE, and it proved to work very well. And so that's what the amorphous silica is, or diatomaceous earth. Now, so we,
So you want, carry on.
So to get it to be able to be used, we liquefied it. And then what do we use liquid? So first of all, we started with water, but we thought that's a bit of a waste of time. So we liquefy it, and we'll get to it later, with amino acids that we make. So these are liquid. So not only does this product, which we call On Guard, kill insects, it also is a nutrient to the plant. Now, the DE, this diatomaceous earth, how does it work? Now, remember I said it was very hard, and it's like crunched up little tin cans, but they're very small. Well, if it's a grazing instrument or grazing insect that chews the plant, it chews this and swallows it, and it cuts the gut. So it's very similar to you putting ground up glass on your toast with your jam of a morning and eating it. It's not too good for you. So this is not too good for the insect. If it's a sucking insect, and any of you are gardeners have had aphids, those very tiny little green or grey insects, or scales, or thrips, and the bane of the hydroponic growers are whiteflies. These are mites. These are all sucking insects. So if this lands on the insect, it tends to absorb the moisture. And insects don't have a very good mechanism for retaining moisture, so they dry out. And when they move, the movement scrapes their skin. It's like me rubbing ground up glass under your arm or between your legs and say, hey, just start moving. It's very unpleasant and cuts. So those insects that don't chew the plant, they are braided and they dry out. And also such as, let's say, a grasshopper, it annoys them immensely. They just don't want to be there by affecting their joints or movement. So that's how this product works. Now, they're in agricultural chemical. One of the key things you've got to watch out for residues. Like if you've got something, we use the term withholding period. And if it's got a 7-day withholding period, that means you can't eat the plant or the crop for 7 days, which is a bit of a problem. With DE, there's no withholding period. And it's used quite considerably as put a teaspoonful in water and drink it. And I think there's a website called Fossil Flour, and it's used in the animal industry for worming cattle, and no doubt it will worm humans and absorb toxins. So, and over time, it solubilizes in the soil. Now, silica gives strength to the plant, and those plants, which are quite tough, are usually very high in silica. So that's the product that Roger mentions, our product On Guard.
So we'll be able to have a look at the website after the presentation. We can go through some of those products. Just tell us a little bit about the testing we've got you.
Okay. Now, remember, all these products emanated from my interest in Ormes or Ormes. And then we needed to have a full range of products, because it's just as easy to sell 6 products as 1 product. And if 1 product works well, farmers are interested in the other 6. And I'm vitally interested in the environment. And I'm probably one of the few people who've seen a pristine situation deteriorate. My very first job was an economic or development officer in Papua New Guinea. And I've been in villages where I was basically the first white person they'd seen. So I'd seen it in its pristine state. And I've been back to Africa since and seen how things have just deteriorated. And the same thing in New Guinea, things are just deteriorating rapidly. So we have an interest in this not happening. So I can go back to the sort of the beginning. Now, Roger mentioned this product, Gotcha. So we needed to have a weed killer. And as you know, universally, Roundup or glyphosate, and Roundup was its first trade name by Monsanto, is universally used. There's about $2 billion worth of Roundup used a year, and basically all manufactured in China. Now, I'll keep using the term glyphosate, but that's what Roundup is. Glyphosate does a good job because it works. And I'm not saying it has environmentally or human toxicologically wise it's good, but it certainly kills grasses and weeds, and it works at very low dose rates, and it's cheap. And this is the problem. And I mentioned right at the beginning, I was involved with the latter end of DDT, and it was used widely for mosquito control all through the tropics because it was cheap. But we realised it has these deleterious effects, and same thing with glyphosate. So it's still widely used, $1 billion worth or more a year. So we looked at, and in a previous company I owned, we developed a product called Slasher, but it had its negative points that it was not quite efficacious enough on certain weeds. So in the company that we have now called South Pacific Biotech, we have a product, we call it Gotcha. Now in Australia, when people explaining something to someone, they say, oh yeah, gotcha. And so it's used all the time. So we thought that was a very clever trademark. So trade name, so that's Gotcha. Now Gotcha's based on 3 things. We have a fatty acid, which is derived from coconut oil or palm oil, called capryllic acid. Capra is Latin for goat, because it is found in goat's milk and actually human milk. And it dries the plant out. When we spray it on a plant, it dries the plant out. And then And right at the very beginning, you would have seen pictures of our plant, a lot of stainless steel and conveyor belts and things like that. Well, we'll get onto that, we convert soybeans into big fermenters, and we produce lactic and acetic acid as a byproduct of our protein manufacture. And so we utilize these organic acids in this product, and they burn. So the fatty acid dries the plant out, the lactic acid and the acetic acid burn, and then to get it to translocate a little, we use clove oil or eugenol. And so this is a world first, and so we have a product. And also in there, we also include our amino acids we make from the soy, and I'll explain how we do that later on. So not only, and these pictures here, and we can get really fantastic results at quite low rates. The label rate will be 25 mils to 50 mils, but in a dip test where I just dip the leaf into the weed leaf into a solution, we get reasonable control at 6 mils, 6 or 12 mils per litre of water. Now that's getting pretty good because the Roundup rate is about 8 mils per litre of water. So we're probably, about twice the dose rate, but we put nutrient back in the soil. So these amino acids, we're killing the top part. What gets onto the soil is food for the soil microbiome, the fungi, the algae, and whatever's in the soil. And so that's what Gotcha is now. It works very quickly. You'll see a result in 15 to 20 minutes, whereas with glyphosate, it'll be sort of 7 to 10 days, you'll see effect. So you'll see a very quick effect, and and it's made from renewable source and it's vegan. So we think this will be great for the environment, and for instance, can be used in broad agriculture. So the farmer tills his land, gets it prepared, waits for 2 weeks till he has a sea of weeds. Then he on the front of his implement for planting his soybeans, he has a sprayer. So he can spray and plant at the same time, which is quite unique. Whereas glyphosate and other chemical weed killers, they have to have a period in between. So that's these pictures that Roger's showing here. So that's...
Because of time, we'll move on. Tell us a little bit about the On Guard product. You've touched on a little bit with the diatomaceous earth. So
yes, so On Guard, as I mentioned, now in the case of these very nasty creatures here, these fig leaf beetles, they're piercing and they're walking above the leaf, so you don't get much contact. But if they're sprayed, it will remove the wax, scratch the wax, and you can see they're waxy, and so they will dry out. Now, diatomaceous earth is very safe, and it's used in beehives in a trap. And now we have a problem in Australia, and it came from South Africa, called a small hive beetle. So we have a trap which is a tube with just a slit in it, that when the bees chase these small beetles, they run into this tube, the horizontal tube with a slit in, and of course we have diatomaceous earth in there. So they get covered with the dust and they die. So it's very safe. And you can see here, these beetles have turned up their heels on the bottom, below there on the white dish. And that's how it's working. There, it's working purely because it's landed on the beetle. That sort of covers that.
Here's some samples of just using the Vigor Grow. Now, remember, the Vigor Grow is more than the Ormes. Tell us about the ingredients in Vigor Grow. It's Ormes based, but
Yes. Now, we use Ormes in every possible formulation we can make because it just has this unique benefit of stimulating growth. Now, the electron, not a lot of work is known as to how it really works, but I'm sure the electron, the cells in contact, and you get this movement because these metals are superconductors. So you get the electron exchange with cells, and we get this excessive, this growth I told you about. But it's a growth accompanied by minerals. You know, you can throw a lot of nitrogen like urea around and whatnot, and you get big plants, but there's no guts in them, if you know what I mean. With Ormes, since you've got all the minerals there as well. So we use it in everything we can, all our formulations. Now, this picture you're seeing here is the, I should explain how we make our nitrogen. And we grow soybeans on big long trays or conveyor belt. And in 6 days, we can get them to be about 12 to 15 centimeters high. Just they're sitting 3 deep on the belt, and we spray them. Our secret is, people said, how can you get them to grow so fast? Our secret is to spray them with the Ormes, right? They're in controlled environment in rooms with LED lights. We spray them, that's all they get, and they really take off. And so they grow that fast, and they're all matted, the roots together, because they're not growing in soil, and they're just rolled up like you get rolled turf. You buy turf here in Australia, and they come down, and then we put them, that blue conveyor belt you saw right at the beginning, into a macerator. Now, I don't know if any of you people have green smoothies every morning, which we do here, made from various weeds and things. Well, it's a giant one of those, and it's a 5,000 litre, and it actually costs about a bit under $400,000. So it's a bit of an expensive machine, and it has an homogenizer attached to it. So it grinds the soybean mass, roots, everything. And remember, they're about 12, 15 centimeters high, and they go through the homogenizer backwards, forwards. So we get it down to a very smooth paste, green paste. It's very similar to the way they make tomato sauce. They put a whole tomato in, and as you know, you don't see any of the seeds or anything like that. So we have this green paste, which then goes into, it's diluted a bit so we can handle it, goes into our fermenters. And I think we've got 5 of those, and 2 of them are the large ones. They're 15,000 litre tanks with this green liquid in, the soybean liquid. And we keep the tanks at 32 degrees, and we add a certain lactobacillus and enzymes. And so in about 12 hours, we've actually digested the soybeans. Thanks, Roger. You can see it there. And you can see my 3 partners. The one in the blue lives in Dubai, and he's very big in food. He's actually a process engineer, and he has the largest corn chip factory in the Middle East. The middle fellow with the big smile, Sam, he grew up in, he calls it Persia, Iran, and has been in Australia for some years. He's I guess, a biological engineer. And there's me at the bottom of the rank there. And I'd run, as I mentioned earlier, I came up through the product development research side till I got to a position where I was managing companies in the Pacific area. Now, on the top left-hand side, that's our homogenizer, and has a massive big motor on it. You can see the man in the blue shirt holding it. And this is when it's being installed, and the soybeans go up into that. And then next to it, you'll see 2 15,000 litre. They're jacketed. That means they've got a double skin. So in between the skins, we can keep hot water, so we keep it at 32 degrees, and they're the stomachs. So we make this high amino acid nutritional or plant nutrition which we mix with the diatomaceous earth. So our On Guard product kills insects and makes the plant grow. We mix it in with our weed killer. The fatty acids and the other organic acids destroy the plant, but the amino acids then is food for the soil. Then we have a fungicide, and the fungicide, and I just accidentally just noted this, that when we used the Ormes or Ormes on plants such as cucumbers, or what in Australia we call zucchinis, and I think in Europe elsewhere they call them courgettes, they are very prone to powdery mildew. You know, they go white, and roses too. So when I sprayed them with the Ormes, it killed this fungal disease. Brilliant. And so we've further developed that, and we mix it with our amino acids, so we can control surface fungal diseases. You may have had a mango which has sort of black end to it. That's anthracnose. And sometimes you get this on mangoes, and certainly powdery mildew on crops. You may have had a strawberry which has gone a bit rotten. That's botrytis. These magical Ormes or Ormes control that. And then with the addition of our soy amino acid, we add nutrition to the plant. Because if you can, we know, and you'll know, if you can keep a plant healthy, you have less insects and less fungal disease. Both these things are sort of cunning things. They will attack the weakened plant. Thank you, Roger. Great. We've got, yeah. This is one of the early experiments where I dipped the leaf in a beaker of the Ormes, our formulation. Now, we do a couple of things. We make it wet better, and we have an organo-silica wetter, like a detergent, but it's a brilliant product, and it's organically certified. It's made from actually rice hulls. Can we go back, Roger, to the powdery mildew? Yep. So I just dipped half that leaf, and you can see the difference. That's in 24 hours. Yeah, so it's a brilliant, and I think it's probably the first organic fungicide that has such a broad spectrum. Previously, I had developed a fungicide based on potassium bicarbonate, which worked reasonably well, but this is much better. And I had set up, and I've sold it, the first organic research-based company in Australia, and it's now owned by my partners decided they wanted to sell. So it's owned by the major home garden company in Australia. Now it has, good, thanks, Roger. Can we go back to this previous, yeah. Now I mentioned this wetter. Half the things in getting products to work is you've got to cover the leaf. Now this is a cabbage leaf, and right on the right-hand side is a nasturtium leaf. Now on the left-hand side, you'll see 3 drops of water sitting on the cabbage leaf, and they'll sit there till they just evaporate. The next picture in the middle, you can see I put a drop of our product which has the wetter in, and see how it's spread. And then when I do a dip test, you can see how it's wetted the leaf. So that's important to get your product so it works. You might have incredibly active product, but it's got to be able to wet the plant and just not run off. So that's an illustration of what we do to get the Ormes to cover the leaf on things that don't like being covered, like a cabbage leaf. And most plants have waxy leaves or hairy leaves, like a tomato. It's quite hairy, and the droplet will sit on top of the hairs on a tomato leaf if you have a close look at it. And most fruit tends to be waxy because water runs off. So they don't, in wet weather, the water doesn't go in by osmosis and the fruit collapse. Yeah, so we've covered the things, this Ormes we use and everything. And one of the reasons why we get such good fungicidal activity with the Ormes, our method is an alkaline extraction method. So the product is quite alkaline, about say 10.6. Now the leaf of a plant is invariably acidic. It's around about 5.5 to 6. And the fungal diseases have evolved in that environment where they like it to be acid. And so here we come along with an alkaline product, and that changes that environment. And so they don't like it, so we use the term in Australia, they cark it. Now, another thing, remember right at the beginning I said associated with the Ormes in the sea, we have magnesium and potassium and calcium and sulfur and phosphorus and silica and boron, etc. Magnesium is a relatively good fungicide, and also sulfur is a good fungicide, and we also have copper, and gold and silver are very good fungicides. And at one stage I'd only really applied for 2 jobs, and the companies kept being taken over. So at one stage I worked for a company that had acquired the company I worked for, a big Swiss company who are big in silver for pharmaceuticals and things like that. So silver I know is a good fungicide, and you would be familiar with colloidal silver. Well, you've got colloidal silver as part of what's in the sea. So our fungicide has these Ormes of these monatomic metals, and that's what works as a fungicide. So you have these metals working as fungicide, it's alkaline, helps it work as a fungicide, and hence we get these brilliant results. And also, there's no withholding period. You know, you could spray and eat in the same day, and in fact, it would be beneficial for you. Environmentally, it's better. It's not produced from the petroleum industry. And when you go and stand on the beach and look out the sea, there's an awful lot of seawater there which we could use. Yeah. Now, Roger's been flicking over here, and you see the word Natra. Well, there's some picture. Thank you for that picture, Roger. Could you go back one? Where the grass? Oh, okay. Yeah, so you can see the left-hand side. It's a piece of grass, a paspalum actually, and you can see how it's died. The middle one, I've just dipped it down so you can see the bottom half is dead, and the right-hand one hasn't been sprayed. Now that picture is about 1 hour with the Gotcha product. So you can see the results are quite good. Thank you, Roger. This is back. This is a very interesting picture. People say, oh, how can you kill weeds and be good for the soil? Now, these are tomato plants in potting mix. And the first on the left hand is just water only. Sorry, these are just cocoa peat and water only. And you see they just haven't progressed because there's no nutrient there. In the second picture, this is a 12.5 mils dilution, 12.5 mils in a litre of water. And I put about 100 mils of that dilution there, planted the plants, and you can see what they're like. The right-hand side is 25 mils. So you can see that's the nutrient effect in the soil. Yeah. So it's 6 weeks post-drench. So those plants are 6 weeks. And you can see the dead weeds there where we've just then planted strawberry runners. Now we can plant immediately. This is the advantage. We have against Roundup and any other chemical weed killers, you have to wait a while. Here we could spray the weeds, as you can see, plant straight away, and that's it. That's right. You can see again a treatment there. So this product will be launched in the USA late this year or early next year. Yeah. Could you go back a bit, Roger? Yes. No, not forward. Yeah, that picture. The top tree is a coffee tree, and you can see very early in the piece. Now, I have to tell you, I do use glyphosate. Now, gotcha, when you've got a solid lawn like that of perennial grasses with stolons, that's long stems full of nutrient for the plant, we burn all the leaves off, but it reshoots again. So in this case, you use Roundup once and you'll never ever need to use it again. So you just come in with gotcha, and you'll see on the bottom right-hand side, you'll see just near the stick, you'll see some whitish weeds which have been killed. Now, I have an interest in breeding coffee because my first job was getting economic development in New Guinea, and so we set up coffee, and I've got a small coffee plantation here, which Roger has drunk some of our material, and I'll come back to that.
I've been drinking that all night.
Okay, fine. And I think I have some of the best coffee trees in the world, and we had these international experts down here the other day, and I can't believe it. But could you go back to that dip one, Roger? That one there. We have a system of quick and easy tests, and we just make the dilution up and we can dip it. And you see, that's at 5 mils to a litre of water. That's a very low dose rate. And you can see above that piece of stick where it's been dipped, and below hasn't. So you've got a dandelion, you've got a rose leaf, you've got a flatweed, piece of grass, and another flatweed. So we've got something which works quite well.
Okay, Leyland, because of time, there's one more product we should talk a little bit about that we haven't covered, and that's the natroponics. Oh,
good. Thank you, Roger. Now, the world, and I've just been reading articles for the months, the world is going, we're running out of water, and we're running out of land because we're abusing it, and so there's a big move to hydroponic growing, on tops of buildings, inside buildings, all sorts of places. And so they just use a lot of chemical. So we started working, and also the medical cannabis, which is grown hydroponically, a lot of it. So we looked at, could we grow crops organically? So we've been doing work, and in the Ormes that we pull out of the sea, I've explained to you there are many other things other than the Ormes. The Ormes part increases conductivity and certainly supplies key things. And so we've found that what we've got works well in hydroponics. And I think for the first time, we can do organic hydroponics. So they don't have to rely on calcium nitrate or urea, which comes from the petrochemical industry, or any of these things. And we don't have to worry about the pH changing of the nutrient and having to adjust that all the time. And plants like us need minor quantities of bit of aluminium, bit of boron, bit of molybdenum, bit of iron. And so we have that in our Ormes product because of the extraction from the sea. So I think we've got a real winner there. And the key part of it is the Ormes part, to get that increase, the ability to grow under less light conditions. So that's what natroponics is. That's organic hydroponics.
And one more ingredient that we should mention, and that's about our volcanic rock extraction.
Oh, yes. Yeah. At the moment, and no matter what country, and I worked for a big British company that had phosphate mines in Morocco, and this rock phosphate is usually of marine origin and can be contaminated with cadmium. And they've got a real problem in New Zealand where they've been using what we call super phosphate, and it's based on this marine rock phosphate, high in cadmium, a few other things which they don't want. And they make that by just reacting the rock phosphate with sulfuric acid. That's what super phosphate is made. And another business associated with mine found waste rock, and there's about 30,000 tons of it from an old ilmenite. That's a titanium mine, and it's just sitting there, and it's quite fine. It's about as similar to sea sand, and it's called apatite, and lo and behold, it's very high in phosphorus and calcium. In fact, higher than rock phosphate. So we've been looking at that, and we milling it down to about 2 to 3 microns, which is very fine. You throw it up in the air and it'll just blow away. And we can solubilize that with these organic acids in our fermenter. Remember I mentioned right at the beginning about the lactic acid and acetic acid, etc. So lo and behold, now we have organic super phosphate, and which will be quite remarkable. This, you can look up this rock called apatite, A-P-A-T-I-T-E. Now this rock was formed, it's an igneous volcanic rock, and this particular place where the mine is, there must have been a hole in the earth, and it came up like a big dome, and it's about 10 kilometres across. And all the soluble has been, over the time, has been removed, and you've got this non-soluble material there, this apatite. It's illuvial.
Okay.
Yeah.
So, Leyland, did you want to just summarize it, and then I'll stop sharing the screen here because we need time for questions as well. Just to let you know, folks, that for instance, on this website, you can see that if you go to the products, for instance, if we just clicked on Fungo, each product has a video that I've done with Sam and Leyland. Quite extensive material there. It takes you through all the detail of each product.
Another product we have in this range, which is organic in base, is a product called Fungo. And all these products I've been talking about, all plant nutrients which have the added benefit of either killing weeds or killing insects, or in this case, killing fungal diseases, surface fungal diseases, which is the main one being powdery mildew. And if any of you people have grown a zucchini, you'll get it covered with a fungal disease. Unfortunately, things are so healthy around this part of the world, we haven't got any fungal disease on it, but yeah.
So there you go. So do take the time to go to each product, and you can research it, read up on about it a lot more. So I'll stop the sharing here. There we go. And we can take some questions. We've sort of got about 5 minutes left for some questions. So I think everybody knows the drill. If you want to, you can unmute yourself. I'll check the chat window in the meantime.
So, Roger, can any of the products on that website, can you order them for the US or not?
Well, good question. We're actually geared up commercially at this stage, right? We're shipping large volumes. And we do have a distributor in the USA. And so early next year, you'll be able to directly contact them for smaller quantities.
Okay.
So at this stage, we're just truly geared up for trade and wholesale, so to speak. And we are finding various companies and distributors globally around. So we're sort of setting up our network as we speak. We've had a few COVID chain supply headaches, like everybody else in business these days, but we are getting through that very, very quickly. And we do think within 1 to 2 months, we are up with full production. So, but yeah, at this stage, we're not doing the domestic market, unfortunately, but that's not to say, you know, in 6 months' time, I'll definitely be able to keep you informed through as long as you're on the Breakthru Technologies database, or if you go to that website, you can join that specific database, you know, www.organicbiotech.solutions. You will see, you can join that database. So we'll be doing regular newsletters and updates. So let's do any other questions. Jenny says, thank you. Hi, Jenny. I haven't had a chance to say hi to you yet, but great seeing you. So Jenny, supply lines need to be fixed. That's right, JK. Yep. Ashley say, looks like Gotcha does indeed have a T. I'm not too sure what you mean.
Oh, that was the spelling, for the spelling.
No, it's, you see, if you spell things correctly, it's a bit harder to trademark. So it's not that Australians can't spell, it's purposely spelt that way. And so in Australia, we spell grow G-R-O-W, but the product is G-R-O. So that helps you. It's a bit like Coca-Cola. You know, you can't, if you've said what Coca-Cola really is, you, cocaine and whatever else is in it was originally, So, but thank you for drawing your attention to that, but it's purposely T-less.
Well, I managed to trademark that in New Zealand. So New Zealand's got a T and USA doesn't have a T. So is it tomato or I say gotcha, you say gotcha. So there you go. Any other questions, guys?
So I do have a question that I just thought of, thinking of all the images of the plants that were kind of, I guess you would say, dipped or coated, particularly like the ones that had the powdery mildew, which is a huge problem here in San Francisco, just because of the moisture in the air and, you know. But when you, I mean, have you, I guess I want to say studied, you know, the long term, but I hate using that terminology, but for lack of a better word, you know, does that kind of coating end up, you know, sort of, I guess what I'm trying to say is, yes, it will it will prevent things like powdery mildew, but will it also affect the plant in its ability to maybe utilize other, you know, like nutrients from the air and things like that?
I can answer that. It'll have a positive effect because the silica gets washed off the leaf, and that's beneficial to the plant. And in hydroponics, they actually spray the plants with silica for that reason. So it has a nutritional benefit once it gets washed off the leaf. And if you eat it and it's on the leaf, on the fruit, let's say it's zucchini, it has a benefit to you for the silica. So it has a positive effect, no negative whatsoever. Yeah, it's a positive effect.
Okay. Yeah.
The only negative effect on, let's say, a rose leaf, sometimes you can see the residue, and the rose leaf it's got to be nice and green. That's as important as the rose flower itself. because I've had a couple of rose growers say, oh, it leaves a tiny bit of a residue, but
So
that would be-
visually, like from a
Visually,
visual
yeah.
standpoint, it's not, you don't want to see that on a rose leaf.
yeah,
Yeah.
Not much, but it's enough to, because people interpret a residue on a leaf as a poison,
Right.
because that's what we've been used to before. We always wash everything to get any of that. But in this case, it's not a poison, but there's still the belief that it could be a toxic substance, but it's not, of course.
Sure.
Yeah.
Okay.
And generally, we're promoting these products as what we refer to as dual action. So it does the job, insecticide, fungicide, but at the same time, it's nourishing the soil, it's nourishing the plant. So
yeah, and I can understand what you say about San Francisco. I spent time there, obviously, and I was based at Palo Alto and at Stanford there. And I couldn't believe that this mist that rolls in from the sea, I'd never seen this before. And powdery mildew loves that misty moisture.
Right. Well, there's a lot of vegetation thrives on that, but others don't. And, and then it varies, with time of year and all of that, but very fascinating. I mean, like Meyer lemon trees do really, really well here for some reason.
Yes. Our gum trees, our eucalypts seem to do well too.
The eucalyptus, eucalyptus.
What big ones there? I was quite surprised.
Yeah, but people complain about the eucalyptus because they're not, quote, native to us here.
And the bark that falls off is a bit.
The bark, and they're very shallow root systems, and they can be dangerous because they can, fall over and blah blah blah. Yeah.
Lenny asks, we are currently using Ormes products to energize our products and are looking to be able to scientifically prove, with the help of one of the presenters in this event, I would like to use some of these products for testing at a later date. Would that be possible? Yeah, sure. I'll speak for Leyland here, Lenny. I think I know, I think we've met maybe in Prague. But anyway, Lenny, yeah, absolutely. Just email me, and when we get a little bit more up to production, we'll be able to organize some samples sent out, especially if you're into doing some trials and testing with them. We're more than happy to coordinate that with you later. So Lenny, do keep in touch with me. Let's see if there's I think we've got to sign off here because of time. We've got Jane waiting in the wings. So any final comments, Leyland?
No, it's been a pleasure to talk to, and Roger tells me that you all are highly intelligent. So it's been a pleasure to talk to such a group of intelligent people. And Australians are a bit simplistic, so I hope you understand what we're doing anyway. Yeah.
Oh, no, we're called the clever country, Leyland. That's because there's a lot of Kiwis living here.
Yeah, okay. Good. Well,
okay, thanks, Leyland.
Thank you very much, and all of you have a great day. Bye-bye.